In section 1.3.2, we will talk about properties of systems. Well, we will describe a system by using properties, okay? For example, we can use the temperature T, volume V, and mass M to describe a full tank of hot water, okay? Here, there is some clarification about the symbol here. Well, in this set of notes, we will use boldface letter to represent volume, okay? So this one is actually not the correct symbol. You will see the correct symbol later, okay? I'll use the boldface letter because we like to distinguish between volume as well as velocity, okay? For the printed panels, we will use boldface letter, but in my handwriting, I would also follow the textbook to use the curly V to represent the volume, okay? So if you are confused about this, please convert it to a boldface letter or draw a curly V to replace this symbol, okay? Okay, properties also include thermal conductivity, velocity, elevation, etc. Okay? Properties can be classified according to their dependence on mass, okay? Intensive properties are those which are independent of mass, for example, temperature, pressure, etc. On the opposite side, extensive properties refer to those that are mass dependent. Volume, momentum, weight are examples of extensive property. The figure on the right shows clearly the classification of intensive and extensive properties. Okay? Suppose I have a bunch of properties here. Suppose you add a partition to split the properties, to split this container into half. Okay? If you see some terms, okay, that is reduced by half. For example, the mass, it will be reduced to m/2, and for volume, it will become v/2. Then these properties, we call that extensive properties because they are dependent on the size of this object, okay, size of the system. But however, you can see that for T, P, and ρ, they would remain unchanged. They would be the intensive properties, okay? But sometimes, in order to remove the mass dependence, because sometimes we would not want to study the contents that is dependent by mass, okay? So we would divide the extensive properties by the mass of the system to obtain specific properties. For example, specific volume V, specific heat capacity C, and specific total energy E, etc. Okay? And again, for this small letter V, please replace it by either the boldface V or the curly V, okay? We will use this to represent volume, while this V will be used for velocity, okay? Please correct it. Another concept is continuum. The word continuum describes matters which is homogeneous, continuous, and contain no holes. This enables us to treat properties as functions defined at each point of the concerned substance. And properties vary across the substance without gaps. The continuum assumption is valid if the volume occupied by the substance is much greater than that of the space between molecules. This assumption is widely used in most of the problems encountered. If the assumption is invalid in some special cases, the rarefied gas flow theory needs to be applied. But we will only focus on the situations where the substance can be treated as continuum. Okay, the next